So this week is going to be going over the bonus lab, which is going to be for chapter 6. So this is lab 11. I guess as one additional clarification, just to make sure that everyone understands what I mean by bonus lab, the way that grading for the lab component of the course is going to work is you technically have 10 required labs plus this 11th bonus lab. So when I go to calculate the average for the lab grade, I'm going to take all 11 of the labs that you did, but then when I divide that, the amount that I'm going to divide it by is just 10. So basically, if you did all of the labs plus this bonus lab, then it's, and you get it completely correct, you could almost kind of think of it like a free 100. So
So
because of
if
that, what's that?
sorry. So if you completed all the labs and like one of them is wrong and you get the bonus lab correct, is this gonna even it up or what?
Yes. So the way that it'll work is for anybody that maybe like didn't do very well in one of the labs or maybe just missed one of the labs, this is almost like a replacement for that. Um, so the types of people that I would most recommend do the bonus lab, if you're mostly just doing it for that reason, would probably be the people that are missing a couple of labs. If you're missing something like 3 or 4 labs and you do this bonus lab, then that's enough to possibly get you to the point of passing the lab, which is very important. Um, and then, of course, for anybody that I hadn't already notified earlier in the semester, things might have changed since then. If you're missing too many labs, like more than 4, I don't know that the bonus lab will necessarily be enough to get you to the point of passing.
Cool.
Yeah. But I will, of course, say that for anybody that's not missing any of the labs, you're only missing like 1 or 2 labs. Your chances of failing the lab are pretty low, so should be fine there. Okay, so that's one type of person. The other type of person that should probably go ahead and do this is basically anybody that's going to be taking the final exam, since this is really good study material for it. So that's everybody. So in the final exam, there's going to be a programming problem that you'll end up seeing. It's going to be very similar. So I noted this in Monday's announcement about this lab, that you'll have this programming problem in your final exam. And the way that it's going to be presented and what you're going to have to do for it is going to look very, very similar to what we're going to be doing for this bonus lab. So the plan right now for the final is that it's going to most likely be that first Thursday once we start the final exams, which is May 6th, I want to say. So I'll probably go ahead and make the next Monday's announcement to actually announce precisely what day I'm going to be doing it and what the expected structure for it is going to be. Plus also including a quick review for the final exam so that you know which main topics from throughout the course you should be studying to prepare for that. Okay, so next we'll go ahead and take a look at the actual directions for lab 11. So lab 10 optional. Well, if you do lab 11, I guess technically it can be. So lab 11 is going to be this person lab. So this one's going to be the last lab we do. It's going to be just a 1-week lab. For this one, not quite as long as the last couple of labs we've had to do. The purpose for this one, so the lab this week is going to focus on implementing a program based on a UML class diagram and some specific behaviors for each of the methods. So you're going to see this class diagram right here to kind of give you a little bit of a hint about the final exam. You're going to see something very similar there, where you're going to get some kind of class diagram and some method specifications. And then based on that, you're going to end up writing your program, which is going to consist of both, some class that was specified with that diagram, plus some kind of demo class to be able to actually run it. And I think for some of you that have already started to watch the Chapter 6 materials, one of the first examples that I use there is the rectangle example. So you see something like a rectangle class and then a rectangle demo to be able to test that class. You'll also notice that the way that that example that I give in the lecture materials is structured is also very similar to what you're doing for this lab and what you're going to be doing in the final exam. So the task here, you're going to go ahead and create a project called person and then your first and last name, or lab 11 and then your first and last name. This project is going to consist of 2 Java files. So this will be one of the first times that we actually start introducing the creation of multiple Java files or multiple classes in our program. So you'll go ahead and create one called person.java and then another called persondemo.java. And then also make sure that you include comments summarizing the program in each of these files. So there's going to be some amount of comments that you want to put into the person, and then some amount that you want to put into person demo. So then going through each step for the task. First, you'll go ahead and review the UML class diagram that's provided above. Keep in mind that this diagram specifies things like the fields and the methods of the class. So you can see 2 fields, 4 methods. It'll also include things like the data types of the fields, the return types and parameters of the methods. It also specifies the access level or the access specifier for them. So you see like the minus sign for private, plus sign for public. So you want to keep in mind all of the different components you'll need to include. So then in step 2, this is where we'll actually get into the programming for this. So in the person class, you'll go ahead and declare 2 fields, the 2 that are specified in this UML class diagram. So that's going to be your name and your SSN. One of the things that I want to be very particular about here is, for the sake of adhering to proper data hiding, make sure that you understand that you see the minus sign here. You'll see it in the examples related to classes. Make sure that the fields are private. And then for step 3, so in the person class, you'll go ahead and write a method definition for each of the 4 methods specified in that UML class diagram. So that's referring to the 4 methods that we see here. So these are going to be your constructor for it, and then the one setter. So it's just going to be related to the name field. So you have one setter for that, and then you'll have 2 getters, one for each field. So one of the things you'll notice about this class diagram compared to how it looks for the rectangle class from the example is that the SSN does not have a setter for it. The reasoning here is that this is supposed to be very similar to how you might have, maybe an actual person in real life, where initially that person is going to have some name and some social security number, and then later on, if they'd wanted to, some people will make this decision to change their name, whether that's legally changing their first name or maybe changing their last name for whatever reason. But generally speaking, you wouldn't expect to see somebody changing their social security number. So we're just not going to include that type of behavior here. But if you ever need to be able to get that information, then of course you'd probably want to make sure that you have a method that can grab either one of those 2 pieces of information. So then kind of just going through each one of the 4 methods here. So these are just going from top to bottom as they are in that class diagram. The constructor will initialize the name field by assigning the passed in value of new name to that field. And then that social security number, you'll notice that there's no passed in parameter for it. So instead, the way that that's going to work is that it's just going to be initialized to some random positive integer. So to do this, you'll just use the random class and then the absolute value method, so that math.abs method, to achieve that behavior. And in a moment when I do the demo, I'll run it a couple of times to be able to show you that that SSN is actually being generated randomly each time. The setter is just going to assign a new name to the name field. And then for the 2 getters, get name method is going to return the name of the person object, and get SSN is going to return the SSN of the person object. So that's going to cover everything for the person class. So then in person demo, this is where we're going to add the main method for the program. And then the main method will accomplish the following set of steps. So first, you'll go ahead and construct an object of the person class and just give it any name of your choosing. You'll then use 2 print statements and each of the getters to display the name and SSN of the object to the console. You'll use the setter to change the name of the field to some other name of your choosing. And then you'll use 1 print statement to display the name of the object. And then to give you an example of what the output for this should look like. So you've got 2 right here plus 1 right here. That's going to be 3 print statements. So you should expect to see 3 lines being printed to the console. So right here, I'm just printing out my own name, some random social security number. And then after I set it to something else, I just go ahead and print out the name a second time. So then going through the criteria, so the comments summarizing the program are going to be worth 5 points. Each field of the person class will be worth 5 points. It's 10 points total since there's 2 of them. The setters and getters for the person class are going to be worth 10 points each. So you got 3 of those, making that 30 points total. The constructor for the person class is going to be worth 15 points. And then the main method is going to be worth 40 points. Okay. So that's going to be everything for the directions. In a minute, I'll switch over to Netbeans and just do a quick run of it, basically just showing this output and then just kind of clarifying that project structure for it. Before I switch over to do that, does anybody have any questions so far? Okay, so I'll go ahead and switch over to Netbeans. So taking a look at this, so I've got my project for it right here, which is going to be this person and then my first and last name. I've got my package right here. And inside of that package, I've got 2 different Java files. So I've got person and person demo. And then you'll also notice the 2 tabs for them, person and person demo up here. So you want to make sure that you're doing the same sort of thing where you're creating your person, which is going to consist of everything that's clarified in this UML class diagram, and then steps 2 and 3. And then in person demo, that's going to be the main method with everything that's outlined in step 4. So then if we go ahead and run this, then we can just see the exact same output that I had right there. But one of the things you'll notice is that this number right here is going to be different from what you saw, since it's just going to be randomly generated. In this case, we've got something like that starts with 195. We take a look over here. You'll see a number that starts with something like 149. And then if you keep running it, then you'll notice that this number changes every time, since we're just going to randomly generate it to keep things kind of simple there. Okay, so that's going to cover the demo for it. As far as the expected behavior for this one, it's pretty simple and pretty straightforward. Yeah, based on the directions and the demo, does anybody have any other questions about this lab?
When's the due date for this lab?
So the due date for this one, if we look at the top right here, is going to be the 28th. So this would be a 1-week lab.
Oh, okay.
Any other questions? Okay.